Good evening. Yesterday, day 1 completed. Today, day 2. Okay. See, now the theorem 1.2. Theorem 1.2. What is the theorem? P divides A square, then P divides A. P divides A square, then P divides A. Means, what is the meaning of divides? Divides means opposite of divided by. Means P divides A square means A square divided by P. Okay? P divides A square means A square is divided by P. Then what is that? A is divided by P. For example, 16 is the A square, means 16 in a sense that is 4 square. Okay, I will write 4 square only. 4 square divided by, I will take any prime number. P is any prime number. Okay. So 4 square is divided by 2. Then 4 is divided by 2. Is it right or not? 100% right? 16 divided by 2 means 2 8 16 is divisible. And 4 divided by 2 means 2 to the 4. So it's also divisible by 2. So that's why this is theorem of 1.2. What is that? P divides A square, then P divides A. This also we can write it as in this format. For example, P, what is that? Same as is. P means 2. P means 2. Divides A square. A square means that is 4 square. Then see P means what is that? 2. Divides A. What is A? 4. Okay. From this we will written like this. For that, for example, this one. From this example, I written like this. What is that? This is the theorem 1.2. Okay. P divides A square, then P divides A. And this is useful in one example. This is root 2 is irrational and root 5 also irrational. We have to prove those. In that we are using this. Okay, right. This is the theorem 1.2. Next, rational and irrational. Listen carefully. Rational and irrational. Irrational. We already discussed yesterday what is rational, what is irrational. So what is rational? Which is in the form of P by Q. Which is in the form of P by Q. So this is a rational number Q, which is in the form of P by Q. Right. What is a rational number? This is denoted as Q dash, which is not in the form of P by Q. We already discussed that. This is one definition of a rational and irrational. One more definition is there. What is that? Another definition means, see, perfect square. Which are perfect square? Which are perfect square? Those numbers are called rational numbers. Which are not perfect square? Which are not perfect square. So that is irrational numbers. Okay, rational means this is another definition. This is first definition and this is second definition. What is that? A rational means which is in the form of P by Q, and another definition is Which are perfect squares are rational numbers. Irrational numbers means which are not in the form of p by q. And one more definition is which are not perfect squares, those numbers also irrational numbers. Another definition also there. For that we have to know. For that, see, I will tell you later that listen. First of all, listen this one means suppose 1.5, 1.5, 1.523 and 1.523, 523, 523 and 1.5555 and so on, and one more 1.5327154322796 and so on. Listen. See, means 1.5 means, suppose for example 3 by 2. What is 3 by 2 value? 1.5 only, right? Means when we divide with 2, when you divide it by 2, this one is will get 0, right? Reminder, see, 2 ones 2 means this is 1 point means that gets 0, 2 5 10. So what is that? Remainder is 0. When we get the remainder is 0, this is called terminating decimal. What we say that this one is terminating decimal. Terminating. What is the meaning of terminating? Terminate means end. That one is end. In any job also, we listen sometimes we listen that those job is means some others are terminated. Terminate means they left, means they send it out. They send out. Okay. So that is a terminating. Right. This is 523. End is there, right? So this is also terminating decimal. This one, this is also terminating. This is also terminating decimal. Then what is this? Terminating is there. So and so on means infinity. You cannot means this is not terminating. Non-terminating. Non-terminating. See, terminating means remainder 0. Is it any repeated? Terminating numbers are repeated after decimal? No. Terminating, non-repeating. Non-repeating. See here, this is also terminating, non-repeating. So not repeated, right? 5, 2, 3. So 5 is different, 2 is different, 3 is different. These three are digits are different. Now see, 5, 2, 3, 5, 2, 3, 5, 2, 3. This is terminating, but it's non-repeating or repeating? Repeating. What is that? Repeating. Okay, this is repeating. See, 5, 2, 3, 5, 2, 3, 5, 2, 3. But this is terminating. Terminating and repeating decimal. Now, this is see this 1.55555 and so on. Is it terminating? It's a non-terminating. 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 This is non-terminating. Is it repeated or not? Yes, it is repeated. Non-terminating, repeated. Non-terminating, repeated. But this one is, see any repeated? Repeatancy is there? See 5, 3, 2, 7, 1, 5. Is it repeated? No, not there. So this is a non-terminating, non-repeating and non-repeating. non-terminating, non-repeating. Okay, so here how many there are? Four types are there. Terminating, non-repeating. This is terminating, terminating, repeating, non-terminating, repeating, and one more is there. What is that? Non-terminating, non-repeating. Okay, four types. In these four types, we'll define another definition of a rational and irrational number. See, what is that? Means rational means in this which are terminating, those numbers are rational. Which are terminating decimals. Terminating decimals are rational numbers. Okay. Next, which are non-terminating. Which are non-terminating is irrational number. Which are non-terminating is irrational number. And one more. See, 5, 5, 5, 5, 5, and so on. And so on is there. But this is terminating. This means this is rational number. Means non-terminating, repeating. Fourth one, non-repeating, non-terminating, non-terminating, repeating, non-terminating, repeating. This one irrational means non-terminating, non-repeating, non-terminating, non-repeating, non-terminating, non-repeating. See how many definitions we got it? Four definitions of rational numbers and irrational number. One more definition is there for log. Now this year they deleted that. Okay, in new books not there. So I'm not saying that. But this must and should do. We have to know that. What is that? A rational. What is a rational? Means which is in the form of p by q. That is rational. Irrational means which is not in the form of p by q. Next, another definition, second one, which is in the form of perfect squares. Which are perfect squares? Those are rational. Which are not perfect square? Those are irrational. Next, which are terminating decimal? Which are terminating decimal? Those are rational. Which are non-terminating? Those are irrational. And one more, non-terminating repeating. Non-terminating repeating means that is rational. Non-terminating, non-repeating is irrational. These are the rational and irrational. And one more, that theorem. See next, one more small definition. What is that means? Co-primes. What is that? Co-primes. Co-primes. Just listen and remember this. What is that? Means GCD of any number. GCD in this sense, that is HCF. Both are same. GCD or HCF. Both are same. So GCD is 1 or HCF is 1. Those numbers are called co-primes. Means suppose HCF of 2, 3. What is that? 2, 3. No common factor. So that is 1. No common factor means the HCF of 2 and 3 is 1. So these 2 and 3 are, what is that? Co-primes. Not only 2 and 3. You can take any example. Suppose the HCF of A, B. Generally we can write A, B is 1. Then A and B are co-primes. Okay. This is the small definition of co-primes and what is rational what is irrational. Okay, now very important question. This is a 8 marks question, very important. 100% you will get in the examination, public examination. Okay, what is that means? The theorem 1.3. Theorem 1.3. What is that means? What we have to prove means root 2 is irrational. We have to prove that root 2 is irrational. Root 2 is irrational. We have to prove that. Okay. If we know this one, we can write root 3. We can prove root 3, root 5, root 7, root 8, root 9, whatever it is. Okay. Let's see that. Root. How we prove this one means we have to prove irrational. So this one we can prove in contradiction method. What is contradiction? Means the contradiction means first whatever they have given means which one we have to prove root 2 is irrational. In the contradiction we are assuming root 2 is irrational. Then whatever we assumed, that one is wrong. We can prove that. That one is wrong means root 2 is not rational. We can prove that. Root 2 is not rational means definitely that is irrational. Okay. Like that we will prove that. So for that, see, same, everything is same. Listen carefully this one. First step is means let us assume that root 2 is rational. Root 2 is rational. Rational means, what is rational definition? First definition, which is in the form of p by q. Right. Okay. So I will write root 2 equals to a by b. So here where a and b are co-primes. A and b are co-primes. Co-primes means, just now I told you, this GCD is 1, means HCF is 1. No common factor for that. How we prove root 2 is irrational means, if these two having common factor, if common factor is there, that is rational. Okay, now we are saying this is no common factor, means co-primes. See how we prove that? Cross multiply. What is that? A into 1, A equals to root 2 into B, root 2 B. Now squaring on both sides. In the examination, don't write SOBS. Okay, you have to write squaring on both sides. They don't know, right? Evaluated, they don't know SOBS means. So you have to write squaring on both sides. So A square equals to root 2b whole square, that equals to root 2 whole square into b square. Square root will get cancelled. So 2b square. This is a square. See, 2 means you will get here divided by 2, right? A square divided by 2 means 1.2 theorem we discussed, right? For that I will write here, from based on that, a square means 2 divides a square. A square 2 divides a square. Then it also divides a, means a square divided by 2. Then a is divided by 2, means 2 is the factor of a. 2 is the factor of a. This meaning is 2 is the factor of a. Right. Next. So this is the equation 1. See, now I'll assume A equals to let A equals to 2C, another number C. Right. Squaring on both sides here also means A square equals to 2C whole square, that equals to 2 square C square. 2 square means 4 C square. What is this? This is A square. See, this is equation 1. Now I will write this is equation 2. Equation 1, check it once. A square equals to 2B square. Here also A square equals to 2C square. LHS are equal, then RHS also equal. Okay, or you can substitute equation 1 in this equation 2, or equation 2 you can substitute in the equation 1. Simply I don't substitute anything, just I equate equation 1 to equation 2. Why? Means LHS is A square, here also LHS is A square. So equation 1 equals to equation 2 1. Equation 1 equals to equation. What is equation 1? 2B square equals to 4C square. B square equals to 2 is multiplying over RHS side is divide. So 4 by 2 C square. 2 ones 2 2s. So B square equals to 2 C square. See, whatever here see here, 2 divides A square. Same in the format, right? So 2 divides B square. 2 divides B square. Then it also divides B. Means here 2 is the factor of A and here 2 is the factor of B. 2 is the factor of A, 2 is the factor of B. What we assume, actually A and B are co-primes. Co-primes means no common factor. But here common factor is there. Common factor is there. So what we assume rational is wrong, right? Whatever we assume root 2 is rational. So that is wrong. That is wrong means definitely root 2 is irrational. So that is the proof of that. So I will write finally here means A and B are, see, this is one, and second A and B are means have common factor 2. Common factor 2 is there, right? For A and B. Common factor is there. So therefore A and B are co-primes or not co-primes, and B are not co-primes. Therefore our assumption is wrong. Our assumption wrong means, what is that? Root 2 is irrational. Root 2 is irrational. This is very, very, very important for 8 marks. 8 marks. This is very important. Okay? Right. Next, root 3. This is not theorem. Let's simply suppose not root 2. Prove that root 3 is irrational. Just replace by 3. Wherever root 2 is there, you have to replace that. This means root 2, right? So this is root 3. Means first step, let us assume that root 3 is rational. Root 3 is rational. So root 2 equals to A by B, right? So here what we have written? Root 3 equals to A by B, where A and B are co-primes. Now A equals to cross multiply it. What is that? Root 3B. Next, a square equals to root 2 is there, right? What we have to write? Root 3 whole square. This is root 3 whole square. Square will get cancelled. This is 3. See, 2 divides a square? No. This is what is here. 3 is there. So, here 3 divides a square. Then it also divides a. See, a and next. Let a equals to 2c. But here 3 is there. This is 3c. Squaring at both sides. Then a square equals to 2c whole square. 2 means that is 3 means this is 3 square. 3 square means what is this? This is not 4. This is a 9. Now equate this equation 1 and equation 2. This is what is this symbol? 3b square. This is 3b square and this is what is this? 9c square. So this one here will get changed. What is that? 9 by 3 c square. 3 ones, 3 threes. So 3 b square equals to 3 c square. Yeah. 3 divides b square, then it also divides b. How will write? A and b have common factor. What is that? 3. 3 common factor. So a and b are not co-primes. So our assumption is wrong. So root 2 is irrational. Okay. This is the very important. Not only root 3. See, root 5 also we can write for this. Root 5, root 7, root 9. Answer not root 10. Root 10 is a rational number. Perfect square, right? So root 5 means here 5. Any rational number you can do same steps, same procedure. No need to change anything. Just write down. 5. Here also, what is that? Root 5. Here, root 5. Here, root 5. Here also root 5 whole square. This here 5 1. So here not 3. Here just 5. Next one. A equals to 5c. Here 5c whole square. Here 5 square. 5 square means this is 25. Here this one is, what is this? This is 5b square. This one is not 9. This is 25. Means 25 by 5. This one is. Right? 25 by 5. 5 ones, 5 5s. So in the place of 3, that right 5. So here what is this? 5 divides b square. Then it also divides b. Right. A and b are having common factor. What is that common factor? 5. So A and B are not co-primes. Okay, why not co-primes? Why not co-primes? Having common factor. Okay, so our assumption is right. So root 2 is irrational. Okay, so this is a very important question, 8 marks. See, next one, example 5. What is the example 5? Root 3 is an irrational. Okay, root 3 already completed. We already discussed, right? Next example 6, 5 minus root 3. Example 6, 5 minus root 3. This one we have to prove that this is an irrational. How to prove this one? This is just only 4 marks question, not 8 marks question. This one is same step. Let us assume that whatever given 5 minus root 3 is rational. Let us assume that 5 minus root 3 is rational. Right. What is rational? Rational means what is how will write? This is in the form of p by q, right? So 5 minus root 3. 5 minus root 3 equals to a by b, where a and b are co-primes. A and b are co-primes. So this root 3 minus root 3, right? So come this side. Mean RHS side will get plus whichever having plus sign in RHS side come LHS side will get negative. So minus A by B. This is already is there 5. So 5 minus A by B means root 3 equals to, I'll write like this, A by B. No problem, right? No change, no sign change, nothing. Just RHS, LHS, LHS, RHS written. That equals to, what is LCM? Here B. So 5 into, what is LHS? So LCM is B. So B into first fraction is 5. So 5 by 1. 5 into B, 5B. So this is 5B minus, next, what is LCM? B is there. So second fraction into A by B. So BB will get cancelled. What is that? A. This is the, what is this? Root 3. See, nothing, we cannot do anything here. Just we have to write some steps. So maximum 4 or 5 steps. For every problem, you can write those steps only. Means just we have to change this one. Whatever we are getting, next problem also, that one also we have to change that. Okay, see how means, if A and B are co-primes, if A and B are co-primes, A and B are co-primes. Co-primes means, if A and B are co-primes, what is this? 5B minus A by B is rational. Rational. See, if this is rational equals to rational only, right? So 5B minus A by B is rational. Root 3 is also rational. Root 3 is also rational. But root 3 is rational. No, this is not perfect square. So 100% this is irrational. So how we can write? But the fact is root 3 is irrational. But the fact is root 3 is irrational. Okay, so root 3 is irrational means this entire 5 minus root 3 also irrational. Then 5 minus root 3 is also irrational. Okay, so this is irrational. Sorry, this is irrational. Okay, right. So this is irrational. So what we assume? This is rational, right? So our assumption is wrong. Therefore, our assumption is wrong. Our assumption wrong means 5 minus root 3 is irrational. Hence proved. So this is the 4 marks question. These steps must and should we have to learn this one. So see, once again I am saying this one. 5 minus root 3 is irrational. So same, first step what we are assuming, just assumption. First step is. So assumption, second step is what is that? We assume what we assume? Rational. Rational means this is in the form of P by Q. So I have written A by B. So here A and B are co-primes. See, this minus plus A by B come this side, minus A by B, minus root 3 come right side, that is plus root 3. So just I interchange that. So root 3 equals to 5 minus A by B. So root 3 equals to 5B means 5B minus A by B. So that's it. We cannot change anything. We cannot simplify that. So keep it like that only. So if A and B are coprimes, this whatever we got it, that one is 5b minus a by b is rational. So 5b minus a by b is rational. Root 3 is also rational. That's it, right? So this is rational means this is equal to, right? Equal to means suppose x equals to 2 means x value 2 1. Suppose x equals to y. So y equals to 5 means x also 5. So here also this is rational means this is also rational. So I written that one only. First step is this is rational. So second step this is rational. This is also rational means root 3 is also rational. But the fact, what is the fact? Root 3 is rational. We know that root 3 is irrational. So but the fact is root 3 is irrational. If root 3 is irrational, then 5 minus root 3 is also irrational. So what we assumed that one is wrong, right? We assumed rational, but that is irrational. So our assumption is wrong. So 5 minus root 3 is irrational. That is the proof of this. Example 6. Next question. Example 7. What is that? What do we have to prove next one? 3 root 2. 3 root 2 is irrational. We have to prove that. First step is same. Let us assume that 3 root 2 is rational. Rational means 3 root 2 equals to a by b. So root 2 equals to a by b is there. So 3 is multiplying, come RHS side, it will divide. So a by 3b. So that's it. So we have to follow these steps again. So what is that? If a and b are coprimes. So here a and b are coprimes. Okay. If a and b are coprimes, this one a by 3b is rational. A by 3b is rational. So a by 3b is rational. Is rational. Root 2 is also rational. Right? Next. But the fact is, what is root 2? Root 2 is rational. Then 3 root 2. Then 3 root 2 is also, what is that? Irrational. 3 root 2 is also irrational. So what is that? Our assumption is wrong. Our assumption is wrong. Means 3 root 2 is rational. Hence proof. That's it. Very simple. We can replace that. That's it. Okay. So 3 root 2. We cannot simplify this, right? So first step is same, second step is same. First step is let us assume that 3 root 2 is rational. Second step is a by b. P by q means a by b. A by b means the coprimes. A and b. That is second step. So root 2 equals to a by 3b. A and b are coprimes. Okay. A and b are coprimes. This total is, what is that? Rational. If a by 3b is rational, root 2 is also rational. But the fact is root 2 is, what is root 2? That is a rational. Then 3 root 2 is also rational. So our assumption is wrong. So 3 root 2 is irrational. This is also just a 4 marks question or 2 marks question, I think. 4 marks. Okay? Right. See, next question. Now examples are completed. Now exercise 1.2. In that exercise, first question is root 5. I already told you. Root 2, root 3 and root 5, root 7 also we can write. Up to root 5, I told you. Root 7 you can write. Root 7 and root 11. You can write those. Okay. So these three are 8 mass pieces. Very very important. Root 2, root 3, root 5. Okay, that is first question. Next, second question. What is the second question? 3 plus 2 root 5. Second question is 3 plus 2 root 5. This is the second question. We have to prove that. What we have to prove? This is irrational, we have to prove. So, first step is, let us assume that, what is that? 3 plus 2 root 5 is 2 root 5 is rational. Second step, 3 plus 2 root 5 equals to a by b, means that is rational, means that is a by b. A and b are coprimes. Next, any problem whichever we have to prove irrational means just keep the whichever having roots, keep it left side only. Whatever remaining are there, just send it to right side. Okay, so 2 root 5 equals to a by b, plus 3 come this side, this is minus 3. What is LCM? This is b. So b LCM, right? b into a by b. So b will get cancelled. This is a minus. So b, this is b, right? Into second fraction is 3 by 1. So 3 into b, that is 3b. Next, what is this? This is a 2 root 5. What is root 5? A minus 3b by b. Already b is there. 2 is multiplying. So come to RHS side, this is will get divided. So root 5 equals to a minus 3b by 2b. Right. Same steps only. No need to change anything. If a and b are coprimes, then a minus 3b by 2b is rational. So a minus 3b by 2b is rational. 2b is rational. Root 5 is also rational. But the fact is, what is that? Root 5 is irrational. If root 5 is irrational, this total also 3 plus 2 root 5 is also irrational. So this is irrational means our assumption wrong. Okay, our assumption wrong. So our assumption wrong in the sense 3 plus 2 root 5 is irrational. Hence proved. This is the second one. You know, exercise 1 point. Right. In third question, what is in third question? Prove that remaining means 3 questions are there. Those 3 questions also we have to prove irrationality. That in that in third question, first one is 1 by root 2. 1 by root 2. The same. Let us assume that 1 by root 2 is rational. So 1 by root 2 equals to a by b, where a and b are coprimes. Right. So we can multiply or we can, this is reciprocal. So root 2 equals to, this fraction is reversible, this one also reversible. So b by a. That's it, right? We cannot change anything. We cannot simplify that. So root 2 equals to b by a. Right. Say again, follow these steps. If a and b are coprimes, b by a is rational. So a by b is rational. What is that? Root 2 is also rational. But the fact is, root 2 is rational? No, that is irrational. So, but the fact is, root 2 is irrational. Then, what is that? 1 by root 2 is also irrational. Therefore, our assumption is wrong. So, our assumption wrong means 1 by root 2 is irrational. Hence, True. That's it. Just a change, just simplified here. These steps are not changing anything. All the steps are only same only. Whatever you got, okay, these type of things just replace that here in these steps. Next question. Next, second question in third one. In third, second question, what is that? 7 root 5. 7 root 5. We have to prove this is irrational. Let us assume that 7 root 5 is rational. 7 root 5 is rational means that is in the form of p by q. So a by b. 7 root 5 equals to a by b, where a and b are co-operands. So root 5 equals to a by b is there. 7 is multiplying RHS side. It's division. So 7b. That's it. Just change these things. Here a and b are co-operands. A by 7b is rational. So a by 7b is rational. Root 5 is rational. But the fact is root 5 is rational. Then what is it? A by root 5 is rational. 7 root 5. 7 root 5 is also irrational. So our assumption is wrong. What is that? 7 root 5 is irrational. Hence, root. Okay. Next. Next question. In third one, 6 plus root 2. Third one, 6 plus root 2. Very simple question, this one also. Just what we had to assume, this one we have to prove irrational. So let us assume that first step is same. 6 plus root 2 is rational. 6 plus root 2 equals to a by b. Why a by b? This is a rational. Rational means in the form of p by b. So a by b. Where a and b are co-operands. Right. So root 2. What I said, this one is any type of these type of questions, just keep it whichever having under root, okay, left side of it. Remaining whatever is there, just send it to right side. So root 2 equals to a by b plus 6 comes this minus 6. So what is LCM? This is b. So LCM is b into first fraction is a by b. B will get cancelled. So this is a minus second fraction. So b into 6 by 1. 6 into b, that is 6. We cannot simplify. So keep it like this one. That's like that. So root 2 equals to a minus 6 by b. Same steps. If a and b are co-operands, a minus 6 by b. A minus 6 by b. A minus 6 by b. This is b. Is rational. So a minus 6 by b is rational. Root 2 is also rational. But the fact is, what is that? Root 2 is irrational. Then root 2 is irrational means 6 plus root 2. 6 plus root 2 is also irrational. So our assumption is wrong. 6 plus root 2 is irrational. Hence proved. Okay, this is the first chapter completed up to now. In second day only completed. If you have any doubts, just comment it. Anything else also, just call me also. I will respond that one. If you comment also, I will respond for those also. If you have, if not understood, I think everyone understood this one. Is very easy chapter. Okay, right. Thank you.